right, so this section here is going to talk about relations necessarily, not functions per se. I remember the difference is that a function has to pass the vertical line test. So here it says if we want to look for symmetry of the relation to be symmetric about the y-axis, that every negative xy on the graph should correspond to a negative xy on the graph. And the way to test this, if we're not looking at it graphically, is to substitute in negative x for x and make sure that the relation is equivalent. Okay, well, that's basically what we did before for even functions, but now we're doing it, say, for a relation. Okay, we can also test for symmetry about the x-axis, which means that for every x, y, there has to be an x negative y, which means we're plugging a negative y in everywhere we see a y. And if we get back an equivalent relation, then we have symmetry about the x-axis. And then finally, we can have symmetry about the origin, and that's for every xy, there must be a negative x, negative y. And to show this, we need to plug negative x in for x and negative y in for y, and show that we get an equivalent relation. All right, so let's go ahead and try these out. The first one here is x to the fourth plus x squared. So let's see if this thing is symmetric about the y-axis. Okay, so to do that, we need to plug a negative x in for everywhere we see an x. So y equals negative x to the fourth plus negative x squared. That's going to give us x to the fourth plus x squared. Remember, negative value to the fourth power is negative times negative times negative times negative, which results in a positive. So these are even powers. When we multiply them, we get back positives. That is exactly what we started with, and therefore this has symmetry about the y-axis. All right, now because this is a relation and not a function, we don't stop there. We have to test the others. So for the next part, it says plug in a negative y and see if you get the same thing. Well, if I do that, I hope it's pretty clear that I get negative y equals x to the fourth plus x squared, which is not the same thing as before. Or if you'd rather, you could move the negative to the other side of the equation, and it would be this. Either way, that is not the same. So this had let's say not symmetric about the x-axis. Okay, and then let's try the origin. So we need to do both of them. All right, so let's plug in a negative y and a negative x at the same time. And so we get minus y equals x to the fourth plus x squared. This is not the same as the original relation. Therefore, and by the way, this symbol here, the 3 dots in a triangle, means therefore, just so you guys know. I'll use that quite often, and that's something you'll see a lot in math. Therefore, not symmetric about origin. Okay. And then let's take a quick look at what this looks like, just so we can prove that we were right. All right, so I went ahead and plotted it. And this is our function, y equal x to the fourth plus x squared. you can clearly see it is symmetric about the y-axis. If I look at a point here, right, I have -1, 2, and then I have, should be, get in the right spot, 1, 2. It is not symmetric about the x-axis. It doesn't even flip over the x-axis. And it's not symmetric about the origin. All right, so let's go ahead and go back to our sheet here and continue. So again, we want to test for symmetry. All right, if we look back up here quickly, doing symmetry about the y-axis means plug in a negative x. So I plug in negative x, and I get minus x cubed plus y squared equals 2. This is not equivalent to the original, right? And remember, I put in a negative x to an odd power. That gives me a negative back. Okay. So if this is not equivalent to the original, this is not symmetric about the y axis. Okay. Now we need to plug in a negative y. So I have x cubed plus negative y squared plus 2. All right, so I plug the negative y in there. Negative y squared is positive y squared. That appears to be the exact same thing I started with, so this does have symmetry. All right, so this is symmetric about the x-axis. Okay. And then we would want to test the origin as well. So we're going to plug in a negative x and a negative y at the same time. This is going to give us minus x cubed plus y squared equals 2. That is not equivalent to the original. So this is not symmetric about the origin. Okay. So again, let's hop over to Desmos just to look at the plot. This time we had x cubed plus y squared, and that equaled 2. Okay, so that's an interesting looking graph. We can see we have symmetry over the x-axis, right? If I take the top half and I flipped it over the x-axis, it looks exactly like the bottom half. It is not symmetric about the y-axis, right? If we look at the right-hand side versus the left-hand side, not the same, and also not flipped over the origin. Remember to have to flip over the x and over the y. Okay. We have one more example here. Let's go ahead and take a look at this. So I have x to the 4th minus 2 equals y to the 6th. So first thing I do is I plug in a negative x. So I have negative x to the 4th minus 2 equals y to the 6th. That becomes x to the 4th. That's an even power. And that is the same. So this is symmetric about the y-axis. Okay. Now I plug in a negative y. And that's going to give me y to the 6th power. That is also equivalent to what we started with. So it looks like it has symmetry about the x-axis. Now, if I have symmetry about both, then I most likely have symmetry about the origin. Remember, we said that if we flip over one, then the other, we should be good, but let's see. So now I have negative for x at the same time that I plug in a negative y. That's x to the fourth minus 2 equals y to the sixth. That again is the same. So we're symmetric about the origin. All right, so let's go ahead and take a look at the plot. So it's x to the fourth minus 2 equals y to the sixth. And so x to the fourth minus 2 equals y to the sixth. Okay. So let's see, if I were to look at this across the y-axis, it's pretty clear that it's symmetric. If I look across the x-axis, right, this portion down here is the same as that portion up there if I were to flip it. So that looks like that is also good. So we have those two symmetries. And then finally, what question is it symmetric about the origin? So if I were to take, let's say, this portion and flip it up there, and then flip it from there across the y-axis, right? I get that. And that does look good. So we are symmetric about the x, the y, and the origin here. So this is quite a unique function. All right, so now we're looking at functions, and we're looking at relations or graphs, and we're asked to first determine, is it a function or not a function? So we have to say, does it pass the vertical line test? And if it passes the vertical line test, then is it even, odd, or neither? So this guy, right, if I were to draw vertical lines, pretty easy to see, he's good to go. This is a function, okay? Therefore, now we would like to know, is it an even, odd, or neither? Well, if we scroll back up for just a second, remember it said for the symmetry about the y-axis, that for every x, y, there's a negative x, y. Well, that was for relation, but that's the same thing for symmetry about the y-axis for a function. And so notice we have a negative x there, right? -2, and we have a positive x, +2. And we could look anywhere else, right? This point right here, we have the exact same point on the other side, but the x value is just opposite in sign. And so therefore, this is even. Now, if it was to be odd, right, it would need to be symmetric about the x-axis. But if I look at below the x-axis and I flip that part above, right, for instance, let's just look at this side here, that's not what we're seeing, right? And so this is not odd. All right. This guy here, notice if we look at the point that's given, well, first let's draw lines, right? Our vertical lines. They all look good. We don't touch the graph more than once. And now if I look, I see that this point, let's just call this XY for a second. This point down here is the same, but opposite in sign. It's -x, -y. So that has symmetry about the origin. And remember that that is the same as saying that a function is odd. Again, if I took this portion here, I flip it over the x-axis, and then flip it over the y-axis, then I get the other part of the function, which means that it is symmetric about the origin. Okay. Let's see what else we have here. All right. This one's easy because the first thing said draw vertical lines. And if I do that, immediately I see that I crossed the thing twice, and therefore this is not a function. Now, if we want to talk about symmetry, right, if it's a relation, we could talk about all the types of symmetry, but we can't say that it's even or odd because it's not a function. Okay. Here we have a linear function, and as you can see, we've got 2 points, -3, 0, and 0, 3. Those don't have the same x value in opposite sign y. They don't have the same y value in opposite sign x. If I took a portion that's below the axis and flipped it to the other side, it's not there, right? So we're not seeing any symmetry here. And that should make sense, right? If I just took a function y equals mx plus b, and I plugged in a negative x, well, then I get minus mx plus b, and that's not the same. And if I took negative of the whole thing, that's also not the same. So it's not even, it's not odd. So linear functions, right, are not even and they're not odd. And again, this is a function because if I draw my vertical lines, they do show up there.